In some cases, you can model a situation with an expression composed of monomials. A monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. Here are some examples of monomials. 18. 18 is a constant. Z is a variable with a whole number exponent, 1. Negative 4x squared. Well, that's the product of a real number and two variables. It can be factored as negative 4 times x times x. 2.5xy cubed. Notice it's also the product of a real number, but this time 4 variables. And a divided by 3, the product of a real number, 1/3, and a variable, a. Some examples of non-monomials. 18 plus z. Notice this is the sum of a real number and a variable. 4x to the negative 2 power, not a monomial. The exponent of the variable is not a whole number. The square root of x, not a monomial. The square root of x is x to the 1/2 power, so the exponent of the variable is not a whole number. And finally on this list, 3 divided by a. 3 divided by a can be rewritten as 3 times a to the negative 1st power, so the exponent of the variable is not a whole number. The degree of a monomial is the sum of the exponents of its variables. The degree of a non-zero constant is 0, and 0 has no degree. Problem 1. Finding the degree of a monomial. What is the degree of each monomial? A, 5x. The degree is 1. 5x is the same thing as 5x to the 1st power, so the exponent is 1. B, 6x cubed y squared. The degree here is 5. The exponents are 3 and 2, and their sum is 5. C, the constant 4. Its degree is 0. 4 can be rewritten as 4x to the 0 power, so we can see the degree of the non-zero constant is 0. Your turn, part A. What is the degree of the monomial 8xy? B. What is the degree of the monomial negative 7 y to the 4th z? And C. What is the degree of the monomial 11?